The choice of models that we use is absolutely critical to the doing of mathematics. And that's because all models are not equal. For a model to be powerful, it needs to have the potential to become, over time, a powerful tool for thinking. We don't want adults carrying Unifix cubes in their pocket when they're in their 20s trying to do a computation problem. So Unifix cubes may be helpful, but if we keep providing the Unifix cubes, they never skip count. They never move to repeated addition or regrouping of groups. They just keep counting. So it's absolutely critical that we begin to introduce certain models at certain points in development as tools. The mathematics is not in the model to be seen. The mathematics is in a child's mind. You can't just hold up a visual picture and expect that children see the mathematics in that model. They're looking at it. We hold up base 10 blocks. They're seeing sticks and flats. They're not seeing the place value that we are seeing as adults. And we have to remember that mathematizing means modeling the world mathematically. So we need to be giving young children a chance, and this goes back to the idea of treating that young child as a budding mathematician, a developing mathematician. We need to be giving them opportunities to determine which model they think would be important to use for a problem. If you compare models, many models have no potential for anything beyond helping kids get answers to some limited problems. Here's an example of some of the insufficient models that we've used in the schools for ages that many of us as adults, when we were in classrooms as children, were used all the time. Unifix cubes, I mentioned already, are going to keep children at the level of counting all. The hundreds chart is something that most teachers have hanging up in their room. Watch a child add 8. All right, they learn very quickly that with the hundreds chart, they can go down a row and go back 2. In other words, if they go down a row, they've added 10. And if they go back 2, that effectively was the same thing as now adding 8. Take the hundreds chart away. Ask them to add 8. It doesn't transfer. They don't add 10, take 2 away. That's a manipulation that they've learned of a way to move around that hundreds chart and read the answer off. That's not learning to operate mathematically. Base 10 blocks are the same. They can use the base 10 blocks to model a multiplication problem, and the algorithm, the partial products are in the base in that array. But it doesn't mean that children are really learning to operate to actually produce those 2-digit by 2-digit would be 4 partial products with the algorithm. Instead, they're just manipulating the blocks, they're building the array, and they're reading the answer off the result of their actions. We've also used the pan balance in the early grades to work towards equivalence. Children don't even understand conservation of weight until around the age of 7 or 8. And here we are with kindergartners placing things on a balance pan. What they're doing is they're reading the answer off the result of their actions. They're not having to think.